In this video, I will show the main malfunctions of a gas water heater that I have personally encountered. We will also talk about the purpose of the adjustment screws on the water block housing. All actions shown in the video are performed at my own risk and for informational purposes only. Do not attempt to repeat anything shown if you do not have the proper experience or authorization. It may be dangerous to your life and property. The first malfunction was the temperature sensor located at the hot water outlet. The heater simply stopped turning on. I opened the tap, but there was no reaction. I ordered a new sensor, installed it, connected it, but the result was the same. The heater remained silent. To be honest, I don't even know what resistance the original sensor was supposed to have. The new one showed 203 kilohms, but the system didn't respond to it. So I decided to take an alternative approach. I installed a 10 kilo ohm resistor instead, and the heater immediately came back to life. So it's possible that the new sensor had a different coefficient or simply wasn't compatible. This is essentially a kind of bypass that imitates the signal of a working sensor. Using this method, you can confirm or rule out that the problem is indeed the temperature sensor. Please note that operating a gas water heater this way is dangerous, so I emphasize that only original spare parts should be used. The water inlet fitting broke. From time to time, I clean the mesh filter at the water inlet to prevent clogging. And during one of these disassemblies, while unscrewing the nut, the fitting simply snapped off. Not only was the wall extremely thin, but the alloy itself was brittle, and it was clear that over time, the metal had become fragile. At that time, I couldn't find a replacement part sold separately, so I solved the problem in an unconventional way. I installed a rubber hose, pushed it tightly onto the remaining piece of the tube, and secured it with a clamp. And it actually worked like that for several years. After a few years, a new problem appeared. Water started dripping from the water block. Not a lot, but directly onto the micro switch. After such a shower, the switch would fail and the heater stopped turning on. The issue turned out to be a rubber seal that no longer held water pressure. I wanted to replace it, but I couldn't unscrew the nut with the rod. Everything was seized. The thread wouldn't move. I only ended up rounding off the edges. However, now I see that it didn't need to be unscrewed at all. I could have tried removing the retaining washer and replacing just the seal itself. At that time, I decided not to struggle with it and replaced the entire water block assembly. And to avoid taking it apart twice, I bought both the gas block and the water block as a set. I assembled everything, started the heater, and here comes a new surprise. It ignites and immediately goes out. I began searching for the cause and discovered that the problem was in the new solenoid valve. It has two coils, the actuating coil and the holding coil. The actuating coil worked. You could hear the solenoid click. The plunger was being pulled in, but the holding coil wouldn't keep it engaged and the flame went out. I checked both coils with a multimeter for an open circuit. Both were intact. But in practice, the valve simply didn't operate correctly. I reinstalled the old valve, and everything worked perfectly, as if nothing had happened. I'm including the resistance measurements of both solenoid coils. On the right is the working one, and on the left, the one that didn't function properly. The difference in resistance doesn't seem large, but it was enough to affect its operation. And the last malfunction, a leak in the heat exchanger. I disassembled it, found the spot where it was leaking, and soldered it with tin. This repair lasted for about 3 years, until a new leak appeared, this time in a place where you simply can't reach with a soldering iron. I didn't think too long about it. I installed a new heat exchanger. With the new one, the heater has been working ever since, without any issues. To conclude, I want to talk about the two adjustment screws located on the right side of the water block. I'll say this right away. You should not touch them, as they are factory set. Everything that follows is provided only to help you understand how the system works. The small screw is located in an auxiliary channel that leads into the flow regulator. It does not bypass the valve. It works only when the main channel is almost closed. In other words, at maximum flow, this screw has no effect. But when the water flow is reduced to minimum, it is the one that determines what minimum flow will still be able to enter the heat exchanger. Under no circumstances should this screw be fully tightened. Otherwise, there is a risk of overheating the heater with no water in the heat exchanger. The large screw regulates a separate channel that leads to the left side of the diaphragm, after the pressure regulator. It has a hollow design with a side opening through which water enters the left chamber. The adjustment is possible only within a small rotation range, as long as the opening in the screw aligns with the channel in the housing. If you turn it further, the opening gets blocked and the flow capacity no longer changes. This screw adjusts how smoothly the diaphragm engages. That's all. Thank you for watching and see you next time.